marked by the team system. So your whether you're in the class, you will be recorded. So don't worry about your how to access your attendance and all this. Teams able to generate report for your attendance. All right. Now, in previous class, I debriefed you on the general information about this Capstone Design 1. So again, make sure you already passed these two modules, right? You need mechanics of material and mechanical design. All right. Just to recap, Capstone Design 1 will continue in the next semester as Capstone Design 2. And at this stage, we're focusing on your design. You come up with a design by end of the semester, and then you materialize it or you fabricate it in Capstone Design 2. All right. Now, I will give you a topic for this module. You have 100% coursework, and you have individual presentation, group presentation, and so on. So you have a project report. By the end of the semester, you need to submit a report 40%. All right. What I'm trying to do here is that maybe I'll break this 40% in phases. So for example, first week you submit what, second week submit separate documents, so you don't need to rush for the final report at the end of the 14 weeks or week 13 or week 14. All right. Yeah. So I'll give you some idea for the project proposal after the holiday, and then you can start generating your design. Okay. Since we'll be doing it in a group, I will group maximum 2 persons in one group. Not me, but you choose your partner. All right, you choose your partner. 2 persons in one group. All right. Then we see how, right? So if we have an odd number, then maybe I will allow 3 maximum. It depends on the situation we have. All right, once our class stabilize, then so at the moment, try to find one partner for this module. You need 2 individual, need 2 in one group, 2 in one group for the projects. I will give you, and you can start think of some idea. You can discuss with your partner, and again, your partner is going to stay along with you together into Capstone 2. So choose your partner carefully. 2 persons in one group, and you generate, and 2 of you will be stick together from Capstone 1 into Capstone 2. So choose your partner wisely. Okay. Okay. Let's do a little bit of lecture today, a short lecture. These are all the references. Don't worry about the PowerPoint slides. I will share with you later. Right. Right. So we go into chapter 1. What is a systematic design? I'll be using this book. This is a bit old, but I think published in 2015, right? 2015, 2016, right? So because the reason I took this book is because of the colorful photo inside there. Okay, so the latest version I have, the picture inside the latest version I have, I do not have color, so it will appear as less interesting when we talk about the topic, or I use the photo from the book that without color. So I choose this book for. But anyway, if you have a more latest version, feel welcome to use it. Okay, the same information, only the photo in this version is more colorful compared to the latest one. Okay, now both textbook is the same author, only this one is the latest one, latest I have, And this one is the older version, but I prefer the photo inside this book. Concept still the same inside there, right? So let's look at a few definition, right? A few definition about design. Okay, so since we talk about Capstone Design 1, you're going to focus on design. So what is design? What is the definition of design? Design is to put something together, to generate something new. Okay, so you put all the components together to generate something new, all right? To generate new devices or to generate a new function. Or it can be a new way to address the customer need, okay, or the society needs. So after this lecture, you can go and find your friend to become a group member. Then both of you can start discussing about what you want to do in these projects, what you want to design, okay, what machine you want to design, okay. Try to think about that. And now basically, if you ask me, I would like to propose to you in our class, when it comes to Capstone 2, I want to showcase your design, and I want to invite you to the international competition. Meaning, for Capstone 1, you've spent more time in the design, but when it comes to Capstone 2, next semester, you will still come into my class in Capstone 2. So when it comes to Capstone 2, the end results, I will invite you to international product competition or conferences where you can present your products. Okay, so have a mental preparedness that every time you submit things to me for this module, think of the future, think of the end results that we are trying to get you to. Okay, so things that you submit for this module, it will lead you to the next semester where your product will be seen by the public and it will be showcased to the publics. Even if your product is so good, it might come out in the news and even you come out in the magazine. So yeah, so I would invite you to pay more attention when it comes to your design. Okay, don't cincai. In Malaysia we use the word cincai, means you just simply do it for this module. That kind of attitude doesn't work in this module. So don't give me things that have low quality. So I might ask you to redo until you reach a very high quality products. Even your products I will invite maybe top management, VC or industry expert to come and look at your design. So that is what I plan for our class. Okay, so have that mental preparedness for Capstone Design 1 and even for Capstone Design 2, so that you can see in what you need to prepare for the future. So just get prepared for it. So again, what is design? Design means you use the existing idea or existing component, existing engineering products, you assembly them to become a new, to produce a new function, or it's a new way or new method to satisfy the current society problem. Okay, I'll just give you an idea of the area that I wish to see in our class is including my own research interests. Now I'm on the way to build a drone system where my team is intent to build a drone system where it can deliver fruit like the Grab system now, where in the future, if you are successfully developed the system, what will the system do? The system, the end user managed to use the system to order, for example, to order Pizza Hut, to order Subway, to order a light food to deliver to your house or to your unit. Okay, so in the exact position, in the exact time, and so on. So this is my research interest. So I hope you can join me in this research idea. So when you discuss with your teammate later on, I will encourage you to think about the drone aspect, the drone delivery system. So this will be my my suggestion to you. Of course, you are open to propose later on. You need to propose your idea and projects to me in this module. So, but I give you an idea on the drone aspect. Okay, so so that we can work together as a team. So because this project is going to be a long run, so yeah, so that is the idea I would like to propose for all of you, right? So you can think of is there any way to deliver Pizza Hut or to deliver Subway or medical devices in that direction. So I would like to propose that. Okay, and I still checking the funding for these projects. If there is no funding from the universities, however, if your projects is related to drone delivery, the funding might come up from my personal account, right? So I might fund your idea, or I will invite you to the research group, and yeah, we will look at your idea and we will fund the expenses of, for example, when it comes to capstone number 2, and your idea was so good, and you need to fabricate it, then I will invite you to be part of my research team, and we will fund all the expenses. When you need to buy things, you need to buy component for the project, then the funding will be from me lah. Okay, so that is my proposal. That is my suggestion to you. Of course, for this capstone design, if you have other idea, I still open up to you. It depends on the discussion with your partner later on. Okay, so by the end of this semester, you need to, for this module, you need to come up with a design of your projects, right? A design of projects, and then next semester, when it comes to capstone number 2, you need to fabricate it and showcase your products. And again, I will bring I'll bring you if you're I'll bring you to the international competition if your design is so good, right? So that will be the direction of capstone 1 and capstone 2 in my class, right? And in fact, you don't get the opportunity to go into international competition if you if you compare to other universities program. So you are in my class, so I want you to open your eyes how people do when they come to international competition. Okay, yeah. So in fact, I was invited for judges in some of the international invention competition. So I would like you to experience the same excitement when you can showcase your products to the public in the conference, in the international competition. So yeah, so again, after this, I want you to group yourself and one partner to become group member, right? Okay. One technical word that you will see frequent when it comes to design is synthesis. So this word might be very bombastic or very advanced or complicated to you, but when people talk about synthesis, it just means put together. Okay, it just means you put together things together. Okay, so synthesis. All right. You will hear a lot of synthesis, the wording synthesis in a international conference where the inventor, this is a very popular word when they present their idea, right? What mean by good design? Okay, how we evaluate your design by the end of semester? How do you score high marks? It involves two things. Okay, involve two things. One, we look at are you using the engineering concept, a solid engineering concept or principle to produce the products? Is there any engineering principle or equation that you use for the design? So there will be some calculation you need to show us by the end of the semester for your design. There will be some calculation for that. Show us what you learn. Then synthesis means you're able to put things together. Okay, you need to put things together to generate products that deliver the needs of the customer or the needs of the society. Okay, these are all the So this is just a textbook explanation. Analysis means you're able to do analysis. You're able to predict the behavior. Maybe you can use, in this case, maybe using equation, you're able to predict the behavior. You learn, I'm not sure whether you learned before how to calculate the life shell of products, life shell of the screw, when you have a rotation, how many times that it can last if you use this material and so on. So something like that. And then nowadays we have all the modern technology, modern simulations. In Manipur, we have AutoCAD, we have CATIA, even SolidWorks, right? So you can use all these tools to do analysis and generate a good report, right? Synthesis means you put all the parts together. You learn in your technical drawing that you have exploded view, you have assembly view, assembly parts and all that. So these are the process for a good design. So when you put things together, does it work? Does it meet the objective, or does it meet the needs of the end user? Okay, these are the things. The next thing is that if you study capstone design, you should come through the 4C design. What I mean by 4C? 4C means referring to the design environment. So this is all the 4C that you can read from the back here. So I'm not going to go through everyone, but you can see the highlighted, the bold C there. The first C is creativity. So if you want to do design, either you cannot run away from creativity, you cannot run away from complexity, you cannot run away from choice, you cannot run away from compromise. So when you do design means you do according to definition just now. What do you mean design? Design means you put things together to generate a new function or a new idea to meet the needs of your customer or meet of the needs of the society. So you need to, creativity also related to new, the wording of new, where you create something, right? You create something, or you can, very similar to synthesis, right? But creativity means you create something new that doesn't exist before. And during design processes, you will come across lots of decision to decide. So before under summarize under complexity area, and then you have a choice. You need to make a choice between, for example, in here you need to make a choice. For example, your design, why do you choose such a shape? Why do you choose a material, and so on? Okay, so it involves choice in your design, and sometimes you need to compromise. You need to let go of the luxury of using a high strength material, for example, titanium, but you replace it with composite because of the material and the working environment. Okay, so this sometimes you need to let go some option, but choose a secondary one. All right. So these are the things. So 4C: creativity, complexity, choice, and compromise. Okay. Design process, we expect to achieve outcome. So what are the design process outcome? One of it is to see the design of the products. So what you see here is the helicopter that designed by NASA for Mars. So you can see the progress of this Mars helicopter on the NASA website. All right. So this is one of the example how we apply the design process. Okay. All right. So yeah. The next thing is that we try to think about why engineering design process is so important. And I'm showing one graph on the screen here. So you will see the y-axis. The y-axis is the performance percentage of products cost committed from 0 to 100. Then the x-axis is the timeline, and the timeline is non-linear, but it's just a concept of how many time you need. And you'll see the vertical lines there, and there's a different phrases there. So the far left, let me see how far I can go. Okay, so this is the most far. Okay, so the far right is the market development. So you start with the market development. You investigate what is the market needs. All right. Then you try out the customer taste or customer needs. Then you have the conceptual design, you have the product design, then you do the manufacturing, and you do the production line. You mass product it. Okay, so if we apply this chart to Capstone Design 1 and 2, so Capstone Design 1 will be on the market development, conceptual design, and product design. So the first three phrases will be Capstone Design 1, and Capstone Design 2 will be overlapping product design, manufacturing stage, but we don't have the, you can say the product use also, right? This is a showcase where you present your projects by the end of the semester. Make sure your projects is, make sure your products or devices that you design is working. Okay, so Capstone Design 2 will be overlapping the design. Manufacturing means you go to the workshop and you fabricate your idea in the workshop with your partners. Then you showcase, you present your products. So how do you apply or how do you use this chart? So basically this chart is an idea of this researcher after our month, right? After our month. So this guy present this idea. It might look so complicated, but as long as you understand the component inside the graph and phrases, let me explain to you what is all these two curved line means to you, and it will help you to do decision in Capstone Design 1. Okay, so let me mark the first point. Let's say in the market development stage, I mark the first point there and I label as A. So let's say you are in the market development stage and you do market research. You go survey, you ask customer, you ask end user, uh, what do they need, and what is the current devices drawback. Okay, for example, I use the example of phone, right? Either you use iPhone, Oppo, Xiaomi, and other brands. So they in the early stage when they come with new design, let's say I put the iPhone 13 Pro as products that haven't launched. Before they launch, they do a market survey. So before they come out with the iPhone 13 Pro Max products, they will do a market survey. So before, then in the market survey, let's say they are at a point A, they make a mistakes or they do misjudgment. I'll draw an arrow there. So you see the bottom arrow, it means this line. You see, it means this line. It means that the cost that the company to pay is very, very low if the mistake done in the market development stage. Let's say you make a mistake at point A. You make a misjudgment during the design processes. The cost to the company actually not much. As you can see below the red arrow, it will be maybe about 5% effect to the company. Okay, let's move on to the second phase. Let's say you have done the first phase, you done all the survey and the result, you are very satisfied and really you understand what is the customer needs and requirement. Okay, then you pass the information, the market needs, the requirement to your design department, okay, to the chief of design. So in your groups, let's say Capstone Design 1, you do survey, right? You do survey. After you do survey for your design, you ask the customer, the end user, this feature, any problem, that feature, any problem. You have all the data already. Okay, so this is what the customer want, or this is what the requirement want. Then you pass your design then you start designing for the devices, right? For the products. So you reach stage number 2, where you start scratching, you start using software to design and run, just draft all these things on a paper, and you come up with let's say you come up with a 10 design. Okay, so you have 2 partners, one partner, each one of you come up with a 5 design, and you combine all the design together. Let's say you get a 10 design, right? So let's say you make a mistake, so you accidentally overlook some of the new needs in the conceptual design stage. Let's say you draw the motor too big, or you draw the shape too big, and so on. At point B, what is the cost to your project? Or what is the cost to the end of the result of the end of the project? If you project down, the effect to your overall progress of your design process actually still below about 10%, not very high. When you make mistake in the conceptual design, you can still make adjustment to the products, because the product haven't fabricated yet. It's just at the conceptual design, just at the table and on the sheet of paper, right? So actually and they haven't spent money to you really haven't spent any money on the material, on the fabrication material. You're still at the idea or conceptual design. So the cost to the overall, the cost that come out from the pocket actually quite low. Then as you progress on, let's say I pick a point when it comes to product design, where you put all the 10 design that you draw with your hand, discuss with your partners, and you come out 10 become 1, the final design. So let's say in the final design, you make a mistake. You accidentally miscalculate one of the parameter. All right. For example, you're designing an iPhone, and when you come to the final design, you accidentally put the camera position in the wrong place. All right, and maybe accidentally you flip the camera from the front to back, or maybe the location is too low or not economic sensors. So let's say you make the mistake in the final in the product design stage. I mark as a mark C there, point C there. If you project down, the cost will be a little bit higher compared to the conceptual design. And yeah, it's about 10% or 15%. However, the cost is getting higher and higher. If you need to have a U-turn or you need to revise your design, the cost is getting higher and higher. What happens if you start manufacturing already, right? Now, manufacturing again, how you apply to your program here. So let's say you already completed your Capstone Design 1 and you go into Capstone Design 2, where you need to fabricate your design that you spend 14 weeks or 15 weeks for the last semester. And you found out that actually you make one of the major mistakes. You choose the wrong material. Let's say you're designing a palm, or you're designing a drone, or designing a wing for the drone, or propeller for the drone, or something that works, rotate or something. You use the wrong material at point D when you do fabrication, or you say you use the wrong material when you fabricate it. The material was so brittle or so ductile that it easily break away when you want to saw it or you want to cut it. You found that the material is so sensitive to the saw that you use, or to the laser. Maybe you use laser cutting to cut the material. If you use plastic, the plastic will melt away when the laser shoot down, and the laser was not suitable for polymer material. So you discover that the method, your design was so great, the simulation run, the simulation result was so good, but the material you choose when it comes to fabrication, you have some issue on the tools that you use. All right, the tools doesn't compatible with, or the tools that you use for your manufacturing or for your fabrication doesn't suit to the situation. So every time you use let's say you use a laser engraver or use a laser cutter to cut a plastic sheet, you always get a melting at the edge, and you won't get the quality that you want. So what happens if you make this mistake at point D? You project down, you'll see that the cost that you need to pay increasing from the last one, from here to here. If you project to the far left, there is about 40%, meaning you need to pay the price a bit higher compared to the mistake that you done before you materialize it. Okay, so you can see the effect. If you don't have a good design, or you do not have follow the proper design process, the cost when it comes to fabrication, it can be double. Right? From here you can see is about 15%, but here is about 30%. It's about double the cost that you need to reverse the design, or you need to redesign the products. You can see here. So keep in mind, when you come to Capstone Design 1, when you start designing, think of the end results. When you come to Capstone 2, will I face this kind of problem or not? Will the material that I use, will I face this problem or not? Will will the design hurt my finger or not, or the end user or not, or if you have any sharp edges that will cut away other component inside the design. So you have to think a bit further. Okay, so this is a reminder in Capstone Design 1. Don't think, oh, Capstone Design 1 only I just need to do a 3D model, or just need to use software to do, or I just need to scratch out a few things. But think of what happens if your design come into Capstone Design 2. It will be, you need to pay the price to redesign all the things that you do in this semester. So just be careful, right? The cost is jump more than that. So, and then when you come to next semester, you learn a more difficult module or more challenging module next semester, yeah, it'll be a loading on you. So try to avoid that, Try to avoid that. What happens if you come to point D? When you fabricate it, almost you want to complete your product already. Almost you want to submit your product for competition. Almost at the time, maybe 1 month or maybe 2 weeks before the deadline. Then only you discover this screw or the screw that I use doesn't work. It always come out when I turn on the machine. The screw always come out, and the screw always eat away the edges of the devices. You can see if you have reached point E and only you discover that you make a very fundamental mistakes because of the screw that you choose, or because of the hole that you make on the design. You can see if I project the arrow down, the costing will be very high, right? The costing, the percentage that you see on the y-axis there, it actually is the total cost of the projects. If you need to redo the whole projects when you come to point E here, you need to spend almost 80% of your total cost to fix the problem. So as you can see here, according to Alman graph here, it just show that you just make 1 point, okay, just 1 point. So maybe I have to work here. All right. So you can see here, sorry, I'm using green screen, so everything is the balik one. So, okay, so it means that from first point you get from this graph that I explained to you is that in decision stage, although the cost is very little, but if you ignore all the mistakes, when it comes to final products, you will have a major effect on the cost. As you can see here, I show you with the A, B, C, D, E, and the arrow of all these, and you project to the left, then you can see the cost that you need to pay if you're not careful enough or you're not detailed enough. All right. Another thing on engineering design process will be product quality. So when you design the process, why design process so important? Because design process will determine or decide the quality, product quality. So from Capstone Design 1, we already can see when it comes to Capstone Design 2, will you win the competition or not? Will you get a title, a gold medal or silver medal or a bronze medal for your products? So design process decide your product quality. All right. So in this here, you see there's a design of automotive. So the design engineer, they actually they are the critical parts when it comes to automotive fabrication or automotive production. When they come up with the design, actually they pay high salary to the product design department. So because the product design department will decide the quality that will come out in the mass production later on. Okay. All right. Again, I want to stress, when you design something, always cross-check that your design is meeting the customer requirement. The next area of design process is more on the product cycle time. Right? What is product cycle time? This word might be new to some of you. Product cycle time means, in terms of management, in terms of production definition, cycle time means from the day you start develop the idea until the time you reach the market. Means from the day you discuss the idea with your friend until the day you fabricate the products. For Capstone 1 is the first day you find your partner, start discussing until the day you submit your report for the idea for Capstone 1. So that is a product cycle time. Okay, but according to the industry, every time you talk, if you work in the industry or do industry attachment later on, product cycle time is from the development time until you launch into the market. So this is an example of iPhone products or Apple products. So as you can see here, from 2007 and then every year almost every year they launch new model. This is how they stay in the market. Okay, this is how they stay in the market. That it brings you to the fourth point. Not fourth point, but the summary of why the engineering process is so important. When we talk about design process, we will focus on quality. Cost competitive means we keep in the low cost but high quality, and you can fabricate in the shortest time, or you can launch it to the market in the shortest time. And this one was shown to you in the picture just now. As you can see, this is one of the examples why Apple can dominate, not dominate, but can be one of the player in the mobile devices market. You can see almost every year they launch new model, right? And the model that they launch actually showing quality. Cost competitive, that one subject to the strength of your pocket money. But those support their products, they know that actually the cost that they pay for high quality products, and they know that their products can last longer, and they know that they also know if you're iPhone, if you are the Apple products fans, you know that even though you buy the iPhone 13 Pro Max, deep inside you know that they're going to launch another model maybe next year, right? So this is how you capture the market, right? This is how the design process will decide on the product itself. Okay, I think let's say go for 2 more slides and we'll stop for the day. All right. So type of the machine, there are a type of design. There are 3. I will just go very fast. First type of design is original design. We call it innovative design. Innovative means something new, something that never people done before. A good example is Intel chip core or Intel microchip, a microprocessor. If you're in the gaming industry, if you play games like your lecturer, me, you know that the graphic card or the memory or the motherboard that you use, you need to upgrade it almost every year if you want to play a very high definition games or a graphic heavy graphic loaded games. Then you know you need to use a good processor for it. So original design in a design process, one example is chip, right? So it means that you are looking at original and new concept. The second type of design, after we look at original, the second type of design will be adaptive. Adaptive means you use the available solution and produce a new application. For example, this is a rapid prototyping machine. The idea to do 3D printing or rapid prototyping machine, they use the concept of printer inkjet. You know the Canon or the 3D printer, not 3D, the inkjet printer. You print A4 paper, you print your coursework, you have the printer, right? So they use the same concept to produce a 3D machine. So this kind of design is fall under adaptive design. Means you use the concept in other area, you create a new machine that meet the customer requirement. Okay, so this is a name for it, adaptive design. The third one, redesign. Redesign type, it means you just improve the existing design. So example of it will be, this is the research done by the NASA, where they redesign the wing using morphing mechanism. So what mean by redesign? This is a textbook definition. Redesign is that it doesn't change anything to the principle, means the equation or the principle used for the design, for example, the wing. You have all the existing design, existing equation to design a wing. However, you change a little bit on the mechanism. For example, this a morphing wing. You change the mechanism inside there to change the profile of the wing, for example. Okay, so you fall under redesign type of design. Okay, I think we stop here and we continue with the problem solving methodology. Okay. All right, let me stop the recording.